Hey guys, Professor Calculus is here, and I'm today here with you with, a, with an interesting integral here. Before, make sure to like and subscribe as it is free and you can always change your mind later. So, to solve this integral, we cannot use any elementary methods like use substitution or integration by parts that we learned in university or school. Instead, we have to use a trick called Feynman's trick of integration or integration under integral sign, differentiation under integral sign. So here, I'm going to take the parameter, I'm going to call this I of a, and I'm going to set it equal to x to the a minus x to the b over x to the c minus x to the d over ln x dx. So I'm just going to recall the thing. If I want to have a derivative of an integral, d dt of a multivariable integral, my integral is going to become the d dt is, when it's going inside the integral, it's going to become a partial derivative. I'm going to be having to take the derivative of this integral only with respect to that parameter. Actually, this had to be a here, but what does this mean to take the derivative partially with respect to a? It means that we don't have to we consider all other the coefficients and powers, all other things that got anything but a in their power are considered constants, and we consider everything here constant except for x to the a. And if I take the derivative of x to the a, I'm gonna be getting, so this here is a constant, this is a coefficient constant, it's gonna remain the same. The derivative of a constant is 0, and I'm gonna get x to the a ln x, because when I take the derivative of an exponential term, it's gonna be x to the that function times ln of the base times x to the c minus x to the d over natural log of x dx. These two terms can be cancelled out, and I'm going to be getting x to the a times x to the c minus x to the d dx. Now this integral is much more simpler to solve because we only got the powers up. Sorry, I'm a little bit tired today. We only got the constant powers, and we can use the power rule. But first, let's expand this, and it's going to be x to the a plus c minus x to the a plus d dx. And if I use the power rule in the integration, it's going to become x to the a plus c plus 1 over a plus c plus 1, the limit from 0 to 1, minus x to the a plus d plus 1 over a plus d plus 1. So the limit from 0 to 1. And if I calculate this limit, 0 to any power is 0, so I'm not going to write it. And it's going to be 1 to the a plus c plus 1 over a plus c plus 1 minus 1 over a plus d plus 1. It's I prime of a. And obviously 1 to the any power is 1. And I'm going to be getting this integral as 1 over a plus c plus 1 minus 1 over a plus d plus 1. Now we can integrate this thing here with respect to a. And if I integrate it with respect to a, I'm going to be getting my integral to be, according to the laws of integrations, 1 over x dx. The integral of that is 1 over d is ln x. Thus, I'm going to write ln of a plus c plus 1 minus ln of a plus d plus 1. And according to the laws of logarithms, I forgot a plus c here, is ln of a plus c plus 1 over a plus d plus 1. Plus is some constant of integration. This constant is so important, do not forget it. And to find this constant, I'm going to write this integral once more. And I'm going to equate it to now here I want to make some trick to be able to find this constant of integration. For doing that, I can use a trick. I can say what is the limit of this these terms here as a approaches b or when a equals to b. If I do that, I'm gonna see that x to the a minus x to the a, which gives me 0, and the definite integral of 0 with respect to any parameter is 0. Thus, this term here, if a equals b, is 0, and c plus ln, so instead of a, I'm gonna place just b, c plus ln of b plus c plus 1 over b plus d plus 1 is equal to 0, and c is equal to negative ln of b plus c plus 1 over b plus d plus 1, and my I of a, I had it here, it's ln of a plus c plus 1, ln of a plus c plus 1 over a plus d plus 1 minus ln of b plus c plus 1 over b plus d plus 1. And I of a is going to be, if I use the logarithm rules again, I can write it as a plus c plus 1 b plus d plus 1 over a plus d plus 1 over b plus c plus 1. And now I'm having this integral, and now I can say the whole integral of x to the a minus x to the b, x to the c minus x to the d over ln x dx is the natural log of a plus c plus 1 b plus d plus 1 over a plus d plus 1 b plus c plus 1. And that concludes the integral that we wanted to solve today with the trick and technique of Feynman, aka the integration under differentiation under integration sign. Thank you for watching this video. Please make sure to like and subscribe, and I'll see you next video.